Right. Well, hello, everybody, and welcome to the 2021 NCWIT B Summit on Women in IT, which constitutes or continues to be the world's largest annual convening of change leaders focused on significantly improving diversity and equity in computing. My name is Dr. Brad McLean. I'm the Director of Corporate Research, and for this session today, I'll be your virtual host. We've decided to kick off each of the meetings each day with a video featuring the 2021 NCWIT Collegiate Award recipients. So today, here's a glimpse of the outstanding work from freshman, sophomore, and two-year institution awardees. We also encourage everyone to attend the B 2021 NCWIT Collegiate Award Showcase on June 3rd to see some more. So sit back and relax for about 2 or 3 minutes as we take a look at this video.
Hi, my name is Laura Lewis, and my project was implementing remote state preparation on a noisy intermediate-sized quantum device. My work is one of the first demonstrations of a classical computer being able to efficiently verify the results of a quantum computation. This demonstrates significant progress in showing that near-term quantum devices work and are useful. What is most unique about my project is that this is the first time this theoretical idea has been achieved experimentally. In the future, I plan to continue researching in quantum computing and cryptography, and eventually obtain a PhD to go on to become a professor.
Hi everyone, my name is Isha, and my project is titled A Scalable and Freely Accessible Machine Learning-Based Application for the Early Detection of Dyslexia. I built an application that's able to predict if a child has a high risk of dyslexia with an accuracy of 90.18%. By implementing a novel, enhanced ensemble of machine learning algorithms, this project was able to produce the first ever eye-tracking methodology that uses the standard computer webcam to screen for dyslexia. Because it's completely free and doesn't require any specialized equipment of any kind, this application has the potential to make highly accurate dyslexia screenings accessible to families all around the world.
Hi, I'm Alexandra Chin. My project is the olfactory communication system, which is an open source device that can identify, measure, and communicate an odorant using K-means and PCA analysis. This project has a wide variety of future applications such as fully immersive VR, food safety, helping those suffering smell and taste deprivation, or even measuring smells in space. We plan to continue improving our algorithm and focus on bettering user experience and accessibility of our app.
Hi, my name is Cathy, and I'm a first-year student at UC Berkeley. My project is focused on mathematical and computational models and simulations for the opioid crisis. The opioid crisis has become increasingly relevant during this pandemic, and my user interface deploys novel SIR models and machine learning algorithms in the backend. I hope to extend this project to tangible technology and policy outcomes in the future. Thank you to NCWIT for this award.
Hi, my name is Alexandra Shefts, and the project that I worked on with my team is a product called Cytoscope. Cytoscope is a Raspberry Pi-powered microscope used to compute CD4 count estimates for patients of HIV or AIDS. Its cell profiler pipeline takes a stained blood smear and outputs the red and white blood cell counts of the sample, making it a unique method for disease monitoring in low-income environments. In the future, Cytoscope could handle blood diagnostic tests for malaria, sickle cell anemia, and toxoplasmosis.
Hello, my name is Victoria, and my project was predicting antihypertensive medication efficacy through machine learning survival analyses in a revascularized patient population. I used old data and new techniques to come up with new insights, and in the future, I'd love to continue on this work and work in other biological areas.
NCWIT appreciates the support of our sponsors, without whom recognizing these technologists would not be possible. Thank you to the NCWIT Collegiate Award sponsors Amazon, Qualcomm, and Palo Alto Networks, and thank you to NCWIT lifetime partner Apple for its generous support of the entire Aspirations in Computing program.
Well, I don't know about you, but I was listening to those projects and thinking about my own projects and thinking I might have to step it up here pretty quick. What an amazing array. And you'll see more in the videos to come of the power of the NCWIT community and the people participating in it. And by the way, if you had some fuzziness to that video, there'll be some ways that you can download it online later on. It'll be archived on the NCWIT Summit site if you want to use that for other purposes and have a clear version. Sometimes on Zoom, it doesn't look so clear. And so once again, we'd like to thank our sponsors that make this entire event possible. And thank you in advance for your patience should we experience any bandwidth or other technical or, God forbid, host-related issues during the show. I encourage you to post your questions, your comments, and any other thoughts that you might have on the Q&A board throughout the session. Don't just wait for the end. Even if you'd like to upvote other questions that you see that you'd really like to have us answered. We're going to be monitoring that and presenting our guests with some of the questions at the end. We'll get to as many of them as we can throughout the whole thing. So let us get started. Algorithms are all around us, lurking behind the scenes. They are in our lives to stay, integrated into every aspect of modern human life, from finances to education, from social media to public health and safety. Algorithms impact how we interact with the world, with each other, and even now with ourselves. But algorithms can and do embed bias. They can propagate or even exacerbate inequality, or they can just plain be inaccurate. How do we make sure the algorithms we build work well? What do we even mean by that? Today, our special guest, Dr. Cathy O'Neil, will introduce the ethical matrix, a construction borrowed from moral philosophy, as a way of organizing our thoughts around important and urgent questions like these. Cathy O'Neil is the author of the New York Times best-selling Weapons of Math Destruction: How Big Data Increases Inequality and Threatens Democracy. She is also a columnist for Bloomberg Opinion and founded the company ORCA, that's ORCAA, an algorithmic auditing company. She earned a PhD in math from Harvard, was a postdoc fellow at the MIT Math Department, a professor at Barnard College, and then she switched over for a time to the private sector, working as a quantitative analyst for hedge funds and banks. She left finance in 2011 and started working as a data scientist in the New York startup scene, building models that predicted people's purchases and clicks. Cathy wrote Doing Data Science in 2013 and launched the LEAD program, LEDE, in data journalism at Columbia in 2014. And today, she is here to talk with us. Thank you and welcome, Cathy.
Thank you so much, Bradley. It's so nice to be here. Great. I was going to ask you to stop sharing so I can start sharing. It's really my pleasure. And today I'm going to talk about bad algorithms and the ethical matrix, which is a construction that I'm hoping will help people avoid the worst of the algorithms. So first, I'm going to define what I mean by a bad algorithm. I call it a weapon of math destruction in my book of the same name. It's characterized with three properties. First, it's making important decisions about lots of people. And usually these are scoring systems. And to be clear, no algorithm makes decisions. Algorithms make predictions, and then people turn those scores into powerful decisions about other people. And I'll try to be careful with my wording because I don't want to lend, consciousness to algorithms. They don't have that. It's humans who are making these choices. But algorithms, an algorithm that is bad is something that is making super important choice decisions about lots of people, or is being used for that purpose. That is secondarily secret, so it's mysterious. People either don't know how their score worked, or they don't even know they're being scored often. A lot of these scores are invisible to us, like they discard our application to a job without us knowing, for example. So they're filtering systems often, or they decide how to render a web page to show us credit card applications that they think we deserve without actually asking us anything about ourselves, but just inferring from our web browsing history stuff about us. So they're secret, they're important because they make they make important decisions about us. They're secret. Already that's problematic because no algorithm is perfect. And if you have a secret important algorithm, its imperfections are not discovered. So the third characteristic is that it's destructive, and destructive not just to the individuals, but as I noted in my book, the biggest WMDs are actually destructive to society as well. And they don't just propagate problems, but they actually exacerbate problems often. I do want to make a couple remarks about this. It's all about context. I will come back to this a million times. Well, I don't have time for a million times, but if I had, I would. Context is everything. An algorithm could be evil or good depending on exactly how the humans in the loop use them. And we can do lots of examples here, but my favorite one is probably an algorithm that is a diabetes risk score. Like, what is the risk of you getting type 2 diabetes within 2 years? This is a real thing. It's happening. If it's owned by your doctor who helps you stay well, that's good for you. If it's owned by a company that doesn't hire you because you look like you're going to be a risky hire, that's bad for you. In particular, the first one keeps you well, the second one gets you sicker, typically. So it's really all about context. So when I say I audit algorithms in a fixed context. It's very important to me to make sure that the distinction is made. You can't really audit an algorithm without knowing how it's being used. The second comment I'll make is that the harms I'm going to describe are for the most part unintentional. I mean, I will give the benefit of the doubt to the people who use them or who built them that they were not intending to be harmful. Often these things, the harms are actually kind of invisible, not only to the people who didn't know they were scored in the first place, didn't know they missed out on an opportunity they deserved, but also to the people who create them, and sometimes to the people who deploy them. So that we're talking about like blind spots on blind spots. And if I have time, I'd like to talk about why I think algorithms and this type of technology of big data is so very good at hiding things from us, even when we're interested in knowing about them. It's a kind of perfect mechanism, if you will, to put accountability at arm's length. Nobody in particular is at fault when a mistake is made, for example. And the final thing I'll say is that there's a lot of feedback loops here. So it's not that obvious what is going to go wrong. And it's also not that obvious necessarily how wrong it's going to go. So you can imagine something goes a little bit wrong, and then the feedback loop is that it actually ends up getting worse and worse and worse. That's the kind of thing I think is happening, in particular with like concepts of inequality. So to the extent that algorithms pick up on people being unequal, so people are deserving versus undeserving, they then give opportunities to the deserving and deny opportunities to the undeserving, whatever that means. I'm not saying it's fair or reasonable, but I'm saying that is kind of what happens. And then the sort of data trail, if you will, of what deserving means and who deserves what is even more entrenched. And so we have this feedback loop. And that concept, again, is something I'll probably come back to. So I want to give some examples of things that can go wrong with algorithms. And the truth is, I have 4 here, but I could have had 90. There's just so many examples. Some of these are in my book, 2 of them are, and 2 of them are not, because they happened since my book came out. I'll start with one that didn't happen, that happened more recently, which is Optum, which is a healthcare company. They were deciding who to pair with concierge service. This is a health insurance company, so they have, patients in their care, or they're paying for the care of patients, and they want to save money, and they also want to help out the patients so that they don't have unnecessary, medical procedures, which is expensive and not helpful. So the idea is get people who have a lot of complicated medical problems to talk to people who are experts on navigating that system, and then you're going to have a win-win. The problem is that they train their algorithm on cost, on historical cost. So I'll just do a really quick side comment that all of these algorithms are essentially scoring systems that say people like you succeeded in the past, so people like you will succeed in the future. They kind of propagate, pattern match, and say whatever happened in the past is likely to happen in the future. That is the sort of naive standard way algorithms are trained. So when you look in the past at people who were very expensive for insurance, well, they tended to have more medical complexity. That was their argument, I assume, for using cost as a proxy for medical complexity. And they said, well, people like you were expensive in the past, so you're like those people, so you'll probably be expensive, so we'll pair you up with this concierge service. The problem is that there's another issue there, which is that some people were sort of systematically undertreated for complicated medical problems, and in particular, African American patients were. So when they chose that proxy of cost for medical complexity, it was not a proxy that worked for African Americans as a group. So the end result was they were less likely to pair a medically complex case if they were African American than if they were white. So that's an example of propagating past bias, but it's also an example of how the wrong choice of target, in this case cost rather than actual medical complexity, can introduce bias. And both of those things are true. The next example is in my book. It's an example of predictive policing. And here you're not scoring individuals, but basically neighborhoods. And you're scoring them as like places of lots of crime or not, and sending police to the places that are highly scored for very likely to have crime committed in them. But again, the proxy is bad. And the proxy here is, instead of actual crime, it's arrests. Now you might think to yourself, oh, arrests happen when there's crime. And that's often true. But the other way around often isn't, which is that there's lots of crime with no arrests attached to them. And I could spend an entire hour talking about the weak link between arrests and crime, but I just want you to think about one crime category, maybe two. The first one I want you to think about is rape. Rapes are almost never reported. They're reported at very low rates. And then once they are reported, they lead to an arrest at very low rates, maybe 7% of the time they lead to an arrest. So maybe 15% of the time they're reported, we actually don't know. But just imagine the set of rapes on the one hand and the set of arrests on the other, and you'll realize that's not a very strong link at all. And it is, and of course it depends on who is raped and who is, it's just, there's so much there. Another crime category is pot smoking, which is sometimes not illegal anymore, but has been historically. White people and Black people are similarly pot smoking, so they have similar rates of smoking pot, but Black people are arrested 4 or 5 times more often for that. So I guess the first point is that there's a lot of missing crime data. And then the second point is that missingness is not equally distributed. So when we use this proxy for crime, which is arrests, in a particular location for arrests, we endow the neighborhoods that have had a lot of arrests, i.e. the neighborhoods that are highly policed, with this sense that they are highly criminal. And we really don't know how accurate that is. We know that the crime versus arrest link is weak. This again propagates a cycle, by the way. This is the cycle of uneven policing. We had uneven policing that led to a lot more arrests in certain neighborhoods. And this algorithm, the use of this algorithm sends those police back to those same neighborhoods to look for crime. They find the crime because they're looking for it, and they arrest more people. So again, that's a feedback loop. The third example also in my book is about teacher accountability. And Bradley mentioned that sometimes these are problematic because they're biased. Sometimes they're just random. Well, this is a random, well, it's both random and biased. I'll say what I mean by that. So there was a teacher accountability algorithm that was essentially, and it didn't have any information. It was almost a random number generator. And yet people were being fired for low scores. People were giving bonuses for high scores. And it's not that there was zero information, because you could game it if you cheated on your students' tests. This picture of Sarah Osaki. She's a person that suspects that some of the teachers of her students had previously cheated and setting her up for a really low score, and then she got fired, even though she's a perfectly good teacher. So I mentioned it's a random number generator. That sounds outrageous, and it is outrageous to be fired by a random number generator. But the bias comes in too, because this teacher accountability algorithm score called the value added model, it wasn't deployed equally everywhere. It was only deployed in urban school districts, essentially. So it was that was the bias. It basically only affected teachers of poor kids. And those teachers often left the schools because they were living in an arbitrary place, or at least the best teachers did. And the feedback loop there is just so tragic, because the idea of the teacher accountability movement was to get rid of bad teachers, but instead the best teachers from those schools were like, I don't need to live with this. I'll go teach in a private school, or I'll teach in a suburb where they don't use this. So there was both unfair and randomness, but there was also bias on where it was used. A final example is recent. It's coming from Amazon. It was reported by Reuters, and I've never been able to I've talked to people who built the other algorithms I mentioned, but not the people who worked on the Amazon algorithm, which I'd love to speak with somebody. They decided to hire engineers with a machine learning algorithm, and they used their own data, in-house data, who applied, who got interviewed, who came, who was successful at Amazon in engineering. They trained their own system, and then they discovered, thank goodness they tested, they discovered it was sexist. They in particular found out that, like, the word Barnard College on an application would give you negative points. The word executed on a resume would give you positive points. For some reason, men execute things more on their resume than women. And so they didn't deploy it, which I find really fascinating. One of the questions I would ask if I could is, what did you do instead? Because if you think about it, if you're like codifying your past practices into code and you find it sexist, you can't just say, oh, well, we won't use this particular algorithm. You have to actually go and examine what you're doing without an algorithm as well. Anyway, these are examples of algorithms going wrong. I hope I give you a sense here that there's no one problem. And because there's not one problem, there won't be one solution. There's going to be no panacea. It's not just about better data. And I'll put that to rest right now. There is no such thing as de-biasing data. That doesn't make sense. I mean, all data has bias. So the real question is, how do we get data that has the bias that we can live with, rather than the bias that we find disturbing and immoral? And that's where I'm going to introduce my concept of the ethical matrix, which I want to say is joint work with the ethicist Hannah Gunn, who now works at UC Merced. Basically, the ethical matrix is a framework for talking about what could be going wrong with an algorithm. And I want it, and because I'm an ambitious person, I want the ethical matrix to be used in every classroom that teaches computer science. And for every computer science machine learning project. In fact, anything that's automated decision oriented, doesn't have to be machine learning, could be a flow chart. I want it to be standard practice to ask the following question: for whom does this work? For whom does this fail? And what does it mean for those people that are impacted that it is failing or that it is working? That seems kind of obvious that we should be asking this. And yet, if you went back to my examples, you'll see that none of those algorithms ask that question. It is a kind of litmus test for me of whether an algorithm has any chance of avoiding major harm. If it's important, of course. If it's an unimportant, benign algorithm that you only built in your basement and isn't used for anything, who cares? But if it is used for important things that matter to people at a high scale, and you haven't asked the question, for whom does this fail, and what does it mean for them that it fails, then it's very likely that it is failing. And when I say fail, I really am broadly speaking any kind of harm. And the thing about that is that this conversation is so rich already. I haven't even, it's non-technical. I'm just going to ask every stakeholder in this system, hi, you're impacted by this algorithm. What would it mean for it to fail for you? What would it mean for it to succeed for you? It introduces such a rich conversation, and it's not a technical conversation. It is a human values conversation. And at the same time, it has things like trolley problems embedded in them. I'll show you one. But just to be clear, this is a conversation that everyone can get in. And then later, the tests come. And what do I mean by that? I mean, we basically want to make sure that terrible things aren't happening. and you're going to be able to test the algorithm for the possibility that those terrible things are happening. But that sort of translation into a person saying what would scare them, what keeps them up at night, into an actual test for a machine learning algorithm, that translation is the job of a data scientist. But that's at the very end. Most of this conversation is not a job of the data scientist. I'm not saying data scientists aren't involved, because they are stakeholders in a data science project. So they are one of the stakeholders, but they are not required for the conversation itself. Ideally, I would want the methodology at the end of the day that was used to audit, this is what I call an audit an algorithm that's important and has high impact. I want the methodology to be as open as possible so that people can see how harm was defined, how success was defined, and how it was measured. Because I'm sure that many of you have been following this conversation, which has been very, very active in the last few years, thank goodness. We don't even have a definition of what it means for an algorithm to be racist. Never mind writ large, we don't even have a definition of a racist algorithm in credit. So you're a credit card company, you want to lend people money, and you want to make sure you're not being racist. What does that mean? We don't have a definition. So this is an ongoing work in progress, and the best we can do right now is say, okay, here's our definition of fairness, and we're gonna, by this definition, here is how this algorithm scores. So we're scoring the algorithm itself at that point. To get down to the nitty gritty, it's a matrix. The rows are the stakeholders. And so it could be like, we're talking about the credit card, it could be like people who apply for a credit card, it would be a stakeholder. But you might want to break that down into people who are white who apply for a credit card versus people who are not white who apply for a credit card, or even further and more granularly. Of course, the people who own the credit card company are a stakeholder. The data people are a stakeholder. The people who created the data are a stakeholder, et cetera. The columns are the concerns of those people who are impacted. And of course, you can't ask every single person who applies to a credit card what they think, but you have to represent their view as much as you can. And the idea is at the end of this, if you've done it systematically and you've considered all their stakeholders and you've asked for all their concerns, you have a kind of mathematically complete view of what could go wrong with this system. And so we consider the cells of that matrix, and some of them are not very problematic and some of them really are. And we rank the ones that are kind of urgently important. We also color code them. Yes, and again, it's practical. It's not an infinite question. It's not trivializing and overly making it overly narrow. It is sort of saying, what are the sort of 6 most important things that might go wrong? How do we measure those things, and how do we mitigate those problems if they exist? And I'm done talking about it in the abstract. I want to give you some examples. So I'm going to go to that example I was just mentioning. And this is coming from, and by the way, I should have mentioned, I also build ethical matrices out of conversations that are already in existence. And so this one is a sort of reflection of an appendix by Maurice Hart, who is a fairness researcher at UC Berkeley. The paper is called Equality of Opportunity. And he has an appendix about a credit company. And to my point earlier, there is no single definition of what it means to be racist. And they make that point. And they say, okay, let's have 5 definitions. 5 definitions. And they're increasingly more stringent. In fact, one of them is there is no rule at all, that you can essentially just optimize to profit with no constraint. And then you have one called single threshold, which does have a constraint, and it goes on from there. It gets more and more tough to meet it. And I'm not even going to go into the definitions, but I want to show you this, because what this is it's a display of how much profit you are sacrificing if you want to use that constraint, depending on the default rate of the customers that you're willing to live with. And what you'll see is that more stringent definitions of racism or fairness with respect to race cut into your profit much, much more. And okay, well, that's not that hard to imagine, but the reason I'm showing this to you is because I'm just making the following point. It's the Wild West right now. We don't really have these definitions down. In credit, it's actually one of the more regulated industries, and there are some notions of what it means to be racist in lending, but not that many, especially in the big data models. And we are developing these things, but until we actually have a stake in the ground, when I say we, I really mean the regulators and the lawyers, until there's actually a chosen definition of fairness with respect to race, every company that actually lends is going to try to get away with using the least stringent one, maybe even the null constraint. Because why? Because they'll make more profit. And moreover, if they choose a strong one, but their competitors choose a weak one, then they're going to lose customers. So it's just one of those things where it will not make sense unless it's a rule that everyone has to follow. So we have to come to an agreement as a culture, as a regulated society. So this is the ethical matrix. Before thinking through this, the company just wants to optimize to profit. That's the only stakeholder in the conversation. This is the ethical matrix that I drew, that I sourced from that appendix. So the appendix basically suggested to consider minority customers separate from white customers, and that their definition of fairness will be their false negative rate, which is much higher than white customers' false negative rate. Why? Because their data quality is so much worse. And again, this is just the ethical matrix that comes from reading that appendix. If I opened up a conversation with everybody in this talk right now, we would have a lot more definitions of fairness to contend with, right? And it wouldn't simply be false negatives. It would maybe be something else. But this is what Moritz Hart and his co-authors considered. And just to put a pin on that, the data quality for minority customers is so much less high quality that they sort of deserve a loan, but they're not offered a loan because it's hard to know whether they'll pay it back. They really can't tell. Of course, that is, again, a very narrow definition of what it means to be fair, but it's the fairness definition that was in that appendix. I wanted to show you, without explaining fully, a couple more ethical matrices that I've drawn. And these are both, again, from conversations that I've read. So the first one, a crime risk score ethical matrix, comes from the ProPublica audit of the Compass recidivism risk algorithm, which you might have read, where it talked about Black defendants' false positives being twice as bad as white defendants' false positives. That's why you get that red box in the top left. And I personally just weighed in with that final column, which is the data quality. And this is something I already said in this talk. We don't have crime data. But the crime risk score, and this is something you'll understand, the crime risk score is that probability that someone will be arrested within 2 years of leaving prison. So remember, I told you that arrests are very bad proxies for crime. This crime risk score assumes they are perfect proxies for crime. So if you're likely to get arrested, then you're likely to be a criminal, is basically the argument. But we know that arrests happen in uneven ways. We know this. So actually what you're doing when you score someone very high risk for being arrested is you're saying you look like someone who will be profiled by the police. And the way these crime risk scores are used, and you should read the ProPublica audit if you haven't, is people who are given high risk scores are sentenced to prison for longer. So people who look like they will be profiled in the future are punished for longer in prison, which, by the way, doesn't help them with their lives and leads to yet another feedback loop of the type I've been talking about, this sort of endless loop of prisons. The lower one, the child abuse hotline, comes from a book by Virginia Eubanks called Automating Inequality. And there's a chapter about child abuse hotline. And I don't have time to explain it all, but guess what? There's racism, and there's classism issues, very serious. But what I wanted to draw your attention to is one of the stakeholders in child abuse hotlines are the children. And we have two red boxes next to the children, which essentially correspond to false positives and false negatives, which essentially correspond to the idea that a child will be overly suspected of being abused when they're not, That would be a false positive. So they're maybe even removed from their home when when they are not being abused. So that's a tragedy for that child and that family. And false negatives where they are being abused, but the system doesn't recognize that. And they are not removed from their home. They're not protected when they should be protected. Also a tragedy for a child and arguably a bigger tragedy. And so the reason I bring this up is because I wanted to show you how the trolley problem for children in this context is surfaced by the ethical matrix. It's surfaced quite explicitly, quite directly. It will be the conversation we have about how we want the system to work. We'll have to ask that question: what is the ratio of false positives to false negatives? What would be the appropriate ratio? That is exactly a trolley problem, but nobody wants to answer that, of course. But the point being, the algorithm actually does answer that. Okay, if we don't explicitly discuss it, that just means that we are implicitly deciding the answer is up to the algorithm. So I think I've made the case that algorithms can be problematic. They can have heavy tolls. Their harms could be real. I also trying to make the case that we need as a society to grapple with this. We need to think about what could go wrong. We need to audit the algorithms, and we need to codify what it means for something to be compliant with either the law, often, as in the case of anti-discrimination law and hiring or insurance or credit, or some kind of sense of values or morals. But I do want to make some caveats. I don't think my firm, Orca, which I love, obviously, I'm doing it for a reason. I don't think it's a slam dunk that this will be a success. And in fact, I will give an example from the world of finance, the credit crisis in particular, where things went really wrong. And so I want to caution all of us that it won't be easy for algorithms to be reined in and their algorithmic harms to be measured and mitigated. Why? Well, first of all, there's a slew of automated fairness tools that are coming out that are just not that useful, if not actually stupid. And the reason I say that is I think I've made it clear that this conversation, this ethical matrix, the context, the details of the context, all of them are important things. You can't skip over all of that and pretend you know what the question is before you've looked at the context. So somebody who tells you they have an AI fairness tool is essentially saying, like, we already have a definition of racist in all of algorithms. It doesn't make any sense. We don't know. We need to know the details. We need to know the law. We need to know the precedent. So automated tools are already a problem. And they're a problem because lots of companies want an easy way to say, we've checked that box. We've made sure that our algorithm is fair. And they don't want to have these long conversations, and they wanted something automatic. For that matter, even if we got pretty good definitions of fairness in a given context, and we did a good, careful job, there is going to be gaming. So we're going to be like, well, we're narrowly agreeing, we're going to sort of narrowly meet the standards that are required, but we're going to actually kind of cheat in other ways. So it's going to look like we're compliant when we're only compliant in spirit, in fact, but not in spirit. Another thing that I've contended with as an algorithmic auditor is companies coming to me and saying, we want you to audit this algorithm for this particular kind of bias. Just, it's super narrow. Like, we don't want you to think about race, but we do want you to think about this particular type of geographic difference or something like that. Well, there's two reasons I don't say yes to this. One is that my system by construction is very broad, right? What does it mean for this to be harmful to you? For whom does this fail? And what does it mean for those people that it fails? Not for the company who owns the algorithm to define failure for those people, but for them to define failure for themselves. And the second thing is, it's very easy. I mean, and the reason I do that is because I think companies will make the wrong choice. They will choose what a convenient definition of failure in a way, in particular, that they succeed. And that's the other thing, which is they can actually do the test for me, right? They can find a definition by which they pass, and they can say, hi, we'd like you to measure the extent to which we pass this particular test, which we're pointing at right here. Well, guess what? They probably have passed it. They already know that. That's not my job, is to sort of rubber stamp something that they've already tried. Of course, there's always the possibility that we choose a bad methodology, or that we have a secret methodology. And so I just want to make the point that all of these things went wrong in finance, all of the things I just mentioned. I worked at a risk firm called Riskmetrics, where the value at risk, which wasn't a terrible idea when it was first invented, was codified to be measured at 95 percentile. And I won't go into the details, but what that basically means is like, what's the worst day out of 20 kind of loss you have? It's not a very bad day, it's just the worst out of 20. And by fixing that number, 95 percentile, we basically allowed people to squeeze all of this intensely bad credit risk into the last 5%. So it was a way of gaming it. Even though the methodology itself wasn't that bad and it was relatively open, it was easily gamed, and it was entirely gamed. And then the mortgage-backed securities and the credit rating agencies, Moody's, S&P, and Fitch, they endowed mortgage-backed securities with AAA ratings. That was both a secret methodology and a bad methodology, which allowed people to trust mortgage-backed securities, allowed the housing market to get really, really big, and in a unreasonable way. So, and I could go on, but the point I'm trying to make is that there's plenty of reason to be worried that the attempts we're making to rein in the harms of algorithms could go the way of finance, and finance, for that matter, just plain old financial audits, audits where you think about Enron, or you think about some of the other big auditing firms that helped Lehman Brothers hide their risk with the tricks that they did. They gamed their audits. So I'm just, I say this all because it's really extremely important for us to set good standards. And those good standards mean the following. We do not make audits narrow. We make audits open. We make sure that they're not easily gamed. And we keep having this conversation as much as possible to help devise reasonable, ongoing rules for what it means for algorithms to succeed, not just for the people that own them, but for everybody who is impacted by them. I think that might be the end of my talk, and I appreciate your attention. I'll stop sharing, and I would love to answer questions.
Wonderful. Thank you, Cathy. And at this point, I am going to share, because I do have some more interesting slides coming up, I promise, but this one just says Q&A. Hopefully you can see it. Oh, so many questions and so little time, but I believe we're gonna be able to spend a few minutes here, and I'll look for my coordinators behind the scenes to pull out the big hook when it's time for us to go off. But I'm gonna pick up on something that you just said, and then I'm going to voice some questions that we've been getting on the chat. You mentioned a couple times regulation needed to build in or implement the ethical matrix ideas that you've been talking about. Of course, there is also the idea out there, and it always has been, that we should just let the market sort this out. We shouldn't overregulate these kinds of things, and that the market-driven forces will be the best solution. And I just wanted to give you an opportunity to explain how you respond to that kind of generalized approach or philosophy as it opposes what you're suggesting.
Well, I guess I kind of prepared for this question, so thank you for it, by that picture from the appendix of Moritz Hart and his co-authors. Like, if we just left it to the market, my argument is that all credit card companies would it would be a race to the bottom, which is to say no constraint whatsoever, or the weakest possible constraint, which wouldn't, in particular, and this was Maury's point, wouldn't motivate innovation. So one of the things that he likes about a stronger definition of fairness in terms of race is that if it's strong enough, it actually motivates large lending companies to improve data quality for minority customers. So at some point they're going to be like, oh, we're leaving so much money on the table because we just don't have very good data, because we don't bother collecting good data. Why don't we actually do the work of getting better data? So like the idea is without rules, we actually we have plenty of evidence that companies will in fact be as unfair as that profitably can be.
And kind of leading right into that is one of the questions we've gotten from the chat that's been going on. And as much as bias may be built into our algorithms, do you view that mostly as bad data, where the data is skewed that goes into the algorithms, the algorithms themselves are skewed, or that they're misapplied, or perhaps some combination of all of those?
Right. I mean, that was kind of the point of my examples, right? It's like I hopefully displayed enough examples to show you that all of those things happen and more. Like I could give you 4 more examples where 4 different other things happen. I mean, it is often the case that the data is problematic. It's either biased or it's missing. So bias in the case of the Amazon hiring, missing in the case of what it means to be a criminal neighborhood. It also is often the case that the definition of success is wrong. It's bad proxy, for example, with the Optum healthcare, or that it is not precise enough. When I talked about the child abuse hotline, the objective function has to punish the machine learning algorithm for failures, either false positive or false negative. And depending on how exactly you adjust that, you're going to get a different ratio of those things. So it's really, really nuanced. But the point I'm trying to make is that there is no one problem here, and there's not going to be any one solution. And let me just back up to the previous question. I just want to make the case that I'm not inventing rules here. Like there already are anti-discrimination laws in hiring, in credit, in insurance. And the point I'm trying to make is that the algorithm, the regulators don't even know how to enforce those laws right now. So I'm not talking about new laws. I'm not talking about just things I want. I'm talking about laws we have on the books that are not being enforced because regulators simply don't know how to do it.
And that leads to another excellent question, so many that we've been getting. Do you have examples of companies that are successfully monitoring the negative impacts of their algorithms, whether it's the algorithms that are going into their products and services or the outcomes that they're having? Are there companies that are doing a good job of self-regulating or looking in the algorithmic mirror, as it were?
I mean, I would like to say that some of my clients are doing a pretty good job, but it's really a big job. You know, algorithms aren't just being used for one thing. They're being used for all the things. In a tech company nowadays, you know, they could hire me to look at 3 of their 400 algorithms, and I might be happy with those 3 monitors, and they are monitors. That's a good way of describing it. So not only do we say, has this been going wrong, but we're like, let's set up a monitor on an ongoing basis to see how it's going in the future, because we have thought through it and we don't want it to go above this threshold or below that threshold or whatever. But as I said, like most companies use dozens of algorithms. So it's hard for me to say across the board, they're doing great. Just hard.
Yeah, definitely. Another question from the group, what about post hoc solutions for problematic algorithms? So instead of just looking at the algorithms and trying to have an in situ solution, what about just letting the algorithms do what they do and then adjusting for such things as you were discussing, risk thresholds, based on what we know about, you know, historical disparate treatment of different groups?
Yeah, I have no problem with that. And one of the questions I would ask the Amazon engineers, because I've heard that they like tried to fix it, but they couldn't. So they threw it away. It's like, well, why don't you just like add points to women's scores, and then it's kind of less biased. You know, not sure. I mean, maybe the answer is like, oh, we don't want to add, well, what if we don't know if it's a man or a woman and we're accidentally giving a man more points than a woman? Like, okay, like that could happen too. But if statistically speaking, you've measured it and the bias is gone, that's a better algorithm than you started with. So I'm with you. I just don't have, I don't have like a perfection complex. I'm just like, get rid of the bias.
So maybe an algorithmic Band-Aid, you know, that put on a bad algorithm is just as good as having a good algorithm. You know,
here's the thing, Bradley, like I'm more of a skeptic than I can't even say that. Like, I think all algorithms are pretty bad. So you're like, it's bad, but not in this way anymore. Mm-hmm. So, and like also hiring systems are bad, human hiring systems. I'm not also not suggesting that we should just stick with humans. Humans are terrible at making these value judgments. They use all sorts of biases. So I'm not against the idea of using an algorithm that isn't perfect, but it at least is not biased.
Right. But, that brings up an interesting point, in a very real way, as a social scientist, always talking about cognitive biases and schemas and how we parse information, data streaming in from our senses into recognizable patterns. We're hardwired to do this. What are your thoughts on how much our algorithms are mimicking this process that we already do internally, individually?
Oh, yeah. That's my first story in my book. Weapons of math destruction. I feel like I'm blurbing it right now, but is like I use an algorithm to cook my dinner for my family. I mean, absolutely. I use an algorithm to get dressed in the morning. Yeah. I remember wearing that. It was successful because I was comfortable. Oh, but wait a second, it's hot, and I was wearing that when it was cold, so it's not comparable. So we do that. We have historical information, we have pattern matching, and we have our definitions of success or failure. So absolutely, we can think of what we do in our heads as algorithms. So they're not mysterious at all. We can also see that we're completely biased if we're honest. So that shouldn't be a surprise. Yeah.
Often we will say, the first task in mitigating our own biases is to elevate them to a conscious, visible level. And in many ways, I hear you saying, let's take a harder look at these things. Let's get definitions for what racism looks like.
Yeah.
In that sense, what if you were to have universal implementation of the ethical matrix? What does success look like for you, or what would it mean to fail? As you're asking the algorithms, what does it mean for this algorithm to succeed for whom, and fail for whom? What would be the answer to that question asked of the ethical matrix itself?
That's a great question. I think the very simple answer is that the algorithms that are huge failures and embarrassments for the comms teams at these companies that keep hiring me, they would have a more interesting problem than they forgot to test if it worked on Black people, which is like unbelievably common, or women, or older people, or any of the protected classes. Like, hey, people, like, you have to think about that. And if you haven't thought about that, you seriously have not done an ethical matrix or any other kind of thing. I mean, I'm not completely tied to the ethical matrix, but what I like about it is it's non-technical and it's comprehensive.
It is one of the arguments of diversifying the field, increasing the inclusive culture in technology, is that by having more diversity around the table, activating that diversity, our algorithms will get better. Is that an assumption that's good to make, or is it not enough by itself?
Well, I don't think it's enough. I mean, to be clear, when I do audits, I actually get the impacted stakeholders in the room, and they're not necessarily internal to the company. Like outsiders, like get those people who are impacted by this system that you've created to talk to us. And that can be done even, I'm not suggesting I'm against the idea of diversifying engineering teams, of course, but you're never going to have like someone who doesn't read on an engineering team, who's like uneducated. There's certain kinds of diversity you're not going to see, but you might care about, you should care about. So I'm totally for diversifying tech companies or any companies that are using algorithms, of course, but it's not enough just to say, oh, we have a diverse staff, so we don't have to think about this. No, you absolutely must.
A great question from the chat. We've just got, on an individual level, as just an individual out there in the world, can people combat the algorithms they interact with on a daily basis? What is the thing we can do or walk away today knowing or changing that we didn't have coming in?
The answer is tricky. I mean, there have been specific people who made it a big difference, and like Joy Buolamwini, my friend who was the star of Coded Bias, and who worked at the MIT Media Lab as a graduate student, and then
Coded Bias being the new documentary that was just released.
Exactly. She and two colleagues, Timnit Gebru and Deb Raji, like audited facial recognition from IBM and others. and found that they didn't work as well for Black people or for women. And they did an enormous amount of work and it had an enormous amount of impact. Of course, they were machine learning researchers. But, the guy who complained on Twitter that, the Apple credit card worked better like for him than for his wife, he had a huge impact. But that's not saying that that most people could have that level of impact. The truth is, this is, as I said at the very beginning, it's like tricky because you often don't even know you're being scored by an algorithm. So you don't know you're being filtered out of an opportunity you deserve either. So you won't know typically how to respond if you don't even know what's happening.
The unseen forces.
The last thing I'll say though, like if you're in a union, like the teacher union, I still don't quite understand why teacher unions were not more active against the machine value-added model for teacher. Although in Chicago, they were pretty active against it. That was part of the teacher strike in Chicago. But in other places, the teacher union was like weirdly passive about this kind of arbitrary random number generator getting people fired. So there's the union aspect sort of it, which I think is important to think about. But at the same time, like you don't have a union of people who applied and got rejected from a job. Like that's not a union situation. So it's limited use, even if you have unions.
Well, and by the way, I was just asked to mention, Joy is also featured in our first issue of the Rethink magazine from NCWIT. So if you want to find out more about the coded bias.
Joy is amazing.
Yeah, we think so too.
Yeah, you're right.
Time for just one more question. In as much as algorithms are reductionist, they reduce us to our behaviors, making predictions and probabilities. Here you come with a moral philosophy-based ethical matrix. How does that compute with a mathematically based force? This kind of relates to the question of what we can do on a personal level. But you came with the idea that we can and should apply a moral philosophy grounding to this math.
Yeah.
What does that imply? That the solutions are not just mathematical, that we're not as reductionist as the algorithms would ascribe us to be?
Look, it's a great question. I guess I'll dumb it down though. I think that data scientists have been given way too much power, way too much to do, and we are not ethicists. We are good at translating rules into code and to testing those rules and making sure that the code is following those rules. That should be our only job. To the extent that we are impacted by the algorithm itself, we are also stakeholders in that discussion. But all I'm saying is that the average person might say, I was never good at math. And unfortunately, they often do say that. And a lot of the power of the WMD, as I described, is power of math shaming. But nobody ever says, I was never good at fairness, right? I was never good at figuring out what was fair. Like, no, everyone has an opinion. Everyone deserves an opinion about their own lives. That's why I'm trying to say the conversation has to be among the people impacted. And then the job of the engineers and data scientists is just say, okay, you guys, you ethical board, if you will, have decided what it means for this to be according to our values, our common values. We'll translate that. So the nerds translate, the group decides on values. Everyone is part of the group.
Cathy O'Neil, that is all the time we have today. Thank you so much. I have the feeling we could go on and on.
Yeah.
What a great way to kick off the NCWIT Summit for this year. And if you can hear that the chat is going up with applause and thank yous, which we'll share with you later.
Thank you.
But we want to thank you very much for appearing.
Thanks so much, guys. Thanks for having me.